Hello, welcome to your food factor part 1 video where we will talk about writing equations from stories. Brief review of independent and dependent variables. In class we talked about this cause and effect situation where independent variables are the cause of change and the dependent variables are the effect of that change. So an example, we looked at putting a beverage in a refrigerator. The cause would be the time in the refrigerator, and the effect would be colder drink. Cause would be you put bricks in a wheelbarrow. The effect is it weighs more. So keep that in mind as you are working with these. Lastly, our independent variable is in the x place, whether that's on a graph where we have our x's right here, or on a table where we have our x's right here, or in an equation where we have our x's right there. And then our dependent variable is in our y's place. So on a graph, that would live here. On a table, that would live here. And in an equation, it lives right there. Let's try out a problem. We're being asked to determine if a relationship between a number of parts, P, and the number of cars, C, is proportional. If it is, we're going to find that constant of proportionality and write an equation to represent the relationship. So I can start with finding my ratios, in this case, of the parts over cars. And so if I say 88 over 2, I get 44. If I say 308 over 7, I get 44. 396 over 9, I get 44. And 572 divided by 13, I get 44. So the answer is yes, it is proportional. And because it's proportional, that means I already know my K. I found this ratio, and therefore since my ratio is constantly 44, that means our constant of proportionality K is 44. Next, let's figure out our independent and dependent variables. So we would say, do the number of parts we order depend on the number of cars we have, or do the number of cars we have depend on the number of parts we have to order? And the more reasonable of the two would be that the number of parts we need to order depends on how many cars we have. So cause, we get cars, independent variable. Effect, we have to order parts, dependent variable. Fill that in. Independent variable is C, number of cars, and our dependent variable is P, number of parts. Now we can write an equation. Since all of our equations are in y is equal to kx format, that is the format of an equation in a proportional relationship. And we know that y is always going to be our dependent variable, and x is always going to be our independent variable. And we found k, that is our constant of proportionality, or that number that always repeats. We can just fill in what we have. So here, our dependent variable is p. Our k is 44. And our independent variable is C. So now we have an equation, and this equation would read the parts we need is equal to 44 times the number of cars we have. Okay, next we said that Katie draws 12 portraits every 5 hours, and we were being asked to write an equation to show the relationship between P, the number of portraits drawn, and H, the number of hours that Katie has been working. So let's start by setting up our independent, dependent, K, and equation. All right, cause and effect. Does the amount of portraits Katie paints cause how many hours she works, or does the amount of hours she works cause how many portraits she's able to paint? And you can make an argument both ways, but the most realistic of the two is that the hours that she works is what causes the number of portraits she can paint. Or you could say that number of portraits she's able to do is dependent on how long she works. So we'd say our independent variable is, in this case, our time, or the hours, H. And time is almost always going to be your independent variable. And therefore, our dependent variable is going to be the number of portraits, P. And since K is the ratio of our dependent variable over our independent variable, we can set this up as our K is going to be the ratio of the number of portraits drawn divided by the number of hours working. And that will get us that unit rate of portraits per hour. So we're going to say 12 divided by 5, which equals 2.4. So what that means is 2.4 portraits per hour. And we can write an equation. So if our equations are always in y is kx format, where y is our dependent variable, k is our constant of proportionality, and x is our independent variable, we have all that information right here. Our dependent variable is p, our k is 2.4, and our independent variable is h. So this equation tells the story of the number of portraits drawn is equal to 2.4 times the hours worked. There's your color coding. Right, here's your turn to try. We have Camping Craze. Hires a graphic designer to create a new logo and marketing materials. The graphic designer charges $45 per hour. Complete the table for the number of hours, H, and the total charge, T, and answer the following questions. Go ahead and pause this, try it, come back and see if your answers match mine. All right, here's what I got. Next step is to watch part 2 and then grab your journal problems and get going. Let me know how I can help you. Thanks.